The derivative of a function can be used in a lot of different ways. We're going to talk about several ways today and then more later on too. But let's call them applications of derivative. And the first one is, it's almost like the very definition of derivative. But let's say I want to find the equation of the tangent line to y equals 1/2 x cubed minus 3x at the point 2 and negative 2. Which is a problem we have done before, but before we relied upon a table or one of those equation, limit definition of the slope of the tangent line. But now we have a tool, we call it the derivative, that will allow us to do this fairly easily, depending upon the function, the equation. But yeah, the equation of the tangent line. Well, again, we're looking for a line, so we're looking for y equals mx plus b. However, we now know that the slope of the tangent line is what we have referred to now as the derivative. So we can find our slope of tangent lines by doing the derivative now. And we know several rules. This one's going to be a fairly simple derivative, and so yeah, so let's utilize that to our advantage here. So what's the derivative here? Well, you got just power rule because you got just have subtraction. Bring down the 3 times 1/2, that'll be 3/2 x squared, subtract 1, and then derivative of 3x minus 3. So that's our derivative, and so how that helps us here now is we now know the slope is the derivative, and we're talking about the slope at 2, negative 2, and so my x value I want my slope at is 2, and so the slope of this tangent line I'm seeking now is the derivative evaluated at x is 2, right? So it'll be 3/2 times 2 squared minus 3. Figure that out, then you got your slope of your tangent line. Now it's what information that provides. 3/2 times 4, subtract 3, so that's 6 minus, so it's 3. Is that right? So that's the slope of the tangent line at this particular x value. And the equation, like we've done before, now we know the slope. The slope is 3, so the equation is y equals 3x plus b. Plug it into y equals mx plus b form, and figure out what the b is. We've got an x and a y, so we can plug those in. The x is still 2, the y is negative 2, so use that here. Yes, negative 2 equals 6 plus b. So it does look like minus 8 is my b. So our slope-intercept form of this equation of the tangent line, we've got a slope of 3. And now we know the b is 8, so it's y equals 3x minus 8. That's my equation of the tangent line. Okay. So we've done that problem several times now, and I guess we can say we'll be settled on this because this is by far the easiest way to do it without having to do a table to find that slope or use that limit definition, which the limit definition is really the definition of derivative. But now that we know the little tricks, the power rule, the product rule, and all those, we can utilize those to find that. Okay, now Here's kind of another little twist on this problem. Find where the tangent line is horizontal for the curve y equals 3x to the fourth minus 8x squared plus 4. Find where the tangent line is horizontal for y equals 3x to the fourth minus 8x squared plus 4. All right, yeah, we could go to the graph here and look, and we could probably estimate where those tangent lines are horizontal. However, let's do a more direct way, a more effective way, because there you're just kind of approximating. Well, it looks like it's at -1, but it may be at -0.9 or something like that. So anyway, yeah. So what can we use here to tell us the answer to this problem? Well, if the tangent line is horizontal, what we can use from what we know is that, for example, if I've got a curve here and I've got a horizontal tangent, what I know is the slope there is 0, isn't it? The slope of a horizontal line is 0. And so I've got a horizontal tangent. And so the other thing that I know, if the tangent line is horizontal, or the slope is 0, what else is 0? So the tangent line is horizontal, so the slope is 0. Which also means, what else is 0? Well, we just talked about the slope is the derivative. And so what I'm looking for here, the way I can utilize my equation, is to find where the tangent line is horizontal, we're going to let the derivatives be equal to 0. So I'm going to get my derivative here. That's 12x to the third minus 16x, right? But I want the tangent line horizontal, and so I'm going to set the derivative equal to 0. So 12x squared, 12x cubed minus 16x, set that equal to 0. And depending upon the type of equation you get, this was just a little factoring, isn't it? I can pull out a 4x. Yeah, so it'll be 3x squared minus 4 equals 0. So I've got 4x. Now I got a factor, we can set those equal to 0. 4x equals 0, 3x squared minus 4 equals 0. Of course, this is an easy one. It's x is 0. And here, if we add 4, 3x squared equals 4, divided by 3, x squared is 4/3. So x would be square root of both sides, plus or minus this right side, plus or minus 4/3. So yeah, so we've got a horizontal tangent at 0, and then plus or minus 4/3. And that's what I was saying. If I looked at the graph here, okay, so let's do that. Graph 3x to the fourth minus 8x squared plus 4. Doesn't look quite like that. Got a W shape, I guess. Something like that. So I can clearly see I've got a horizontal tangent, horizontal tangent, horizontal tangent. Now, x is 0, that's an easy one, but these x values, well, it turns out they're plus or minus 4/3, which is, that's not a nice whole number, integer, either. So yeah, it turns out those are plus, that'd be the negative square root of 4/3, and that'd be the positive square root of 4/3. And there's just no way you would be able to guess that from the graph there. So this gives a way to find those exactly and to verify it, if you will. So, you with me? Is that okay? All right, now, there's also, in addition to our tangent line, there is sometimes call for finding what's known as the normal line. So let's talk about normal lines here for just a second. All right, so here's kind of the picture. We've got point P, and we know about the tangent line at point P. We can find it with the derivative now. Call it tangent line T. Well, the normal line is simply that line that's perpendicular to the tangent line. So it goes, if you're wanting the normal line at P, it's the line that is perpendicular to the tangent line. At point P. So if I draw the normal line in here, just kind of give you a visual. Yeah, it's going to be 90 degrees to that tangent line. That's going to be the normal line. Simply what it is, okay? It's just the line that goes perpendicular to the tangent line at whatever point. We're going to put P in there. At whatever point you want it at, okay? So, this gives us a way of finding a normal line now, since we know how to find the tangent line slope. And we know that how are perpendicular lines, how are they related, slope lines? Perpendicular lines are, well, they have the opposite value, non-horizontal and vertical lines. They have the opposite slope. This one's positive, this one's negative. So they're opposite, and then they're also reciprocals. So if we find our tangent line slope, then we just do the opposite reciprocal, and that's the slope of the normal line. For example, let's say, we'll just make one up. Let's say we've got the slope of our tangent line at point P is 3/2. Well, then the slope of the normal line, since it's perpendicular at that same point, if the slope of our tangent line is 3/2, then at the same point, the slope of the normal line, opposite reciprocal, so it's -2/3. So that's how you do it. You find, if you want the normal line slope, you just find the tangent line slope, because we know it's the derivative, and it's the opposite reciprocal. Okay? So here's one of those. For example. Okay. Find the slope of the tangent line and the normal line. To y equals the cube root of x minus x squared at the point 1, 0. On the slope of the tangent and the normal line to y equals cube root of x minus x squared at 1 and 0. All right, so we start with the slope of the tangent line. It's, again, by very definition, slope of the tangent line is the derivative. So we start with the derivative. Now, again, the cube root of x, that works best if we change that over to x to the power of What power is cube root? 1/3? 1/3 power. So the derivative is 1/3, bring down the power, subtract 1 to get the new power, so that'd be -2/3. And then the derivative, since this is just subtraction, we're just doing the derivative of these separately. The derivative of x squared just be 2x, right? 2 times x to the first. So the slope of my tangent line is the derivative. And in this particular case, I've got the x value is 1. And so the slope of my tangent line is going to be, evaluate that at 1 from this particular point. Plug in the 1. Of course, 1 to anything is 1. So 1/3 minus 2. So the slope of my tangent line is -5/3. Best way to write that. And once you have the slope of the tangent line, then the slope of the normal line follows, because the slope then of the normal line is just the opposite reciprocal. So you don't even have to calculate anything. You just have to do your opposite reciprocal. 3/5 positive. Yeah, it turns into a positive. And the reciprocal is 3/5. All right.